Good morning, students. In the last class, we studied resistors in series. Today, we'll see resistors in parallel. Here, we have circuit diagram where resistors are connected in parallel. Let us understand how circuit works when it is in parallel through an activity. Look at the circuit diagram. The battery, key, ammeter are connected to resistor in parallel where these resistors are connected to voltmeter. The first step is plug the key and note down the ammeter reading as well as voltmeter reading. Let our current be I, this is our first reading, and voltmeter reading be V. And in the second step, now we'll just see about potential difference, that is voltmeter reading. Now we took voltmeter reading which was connected across the three resistors. The next step is we'll take voltmeter reading across the each individual resistors. So what happens if you connect for the first resistor, we got some value, let it be V1, and when we place voltmeter in the second resistor, we got the same value, let it be V2. And in the next step, when we connect the voltmeter in the third resistor, again we got the same value. That indicates all the three resistors have same potential difference value. And we got one more value across these three resistors, that is V, right? So now here we understood that after looking the three potential difference values of each individual resistor and voltmeter reading of all these three resistors, it indicates that the potential difference across each resistance is the same, that is all V1, V2, V3 are same and is equal to the potential difference across the combination. That means all these three readings is sum of the potential difference value of all the three resistors. That point we can write as V is equal to V1 plus V2 plus V3. Now just go back to the earlier class. What we studied in series, we got I, that is current, is equal to I1 plus I2 plus I3. So there current was constant and we got different voltmeter values. But here in parallel, the potential difference, that is V, is same throughout the circuit. So remember, in series current is constant or same. In parallel, potential difference is same or constant throughout the circuit. This is our first point in the resistors in parallel. Now we will see what happens to the ammeter reading, that is current. First we already took ammeter reading, right? We got some value, let it be I. Now we need to change the place of ammeter in the or across the each resistors. So if we place here ammeter and if we note down the current value, we got current value, let it be I1, and the same thing if we repeats to the R2 resistor, we got another different value, let it be I2. And the same thing if we repeat in the third resistor, we got another different value. So here I3. So when we are measuring current, we observe that current flows with different values across each of the resistors. But the sum of all the current is equal to the total current of the circuit. Therefore, from this we understood that current will flow with different values in each of the resistors. Now let us take this as our equation 1. I is equal to I1 plus I2 plus I3. Now we know that on applying Ohm's law, that is V is equal to IR. We can take it as I is equal to V by R. Now we measured both potential difference as well as current, right? So let us consider R1, R2, R3 resistors have I1, I2, I3 current and V1, V2, V3 current, but we can take V as the same value, right? Because V is constant in parallel. So now we will write I1 equal to V by R1. You understood, right? Why we are not writing V1? Because potential difference is same. Now what happens? I2 is equal to V by R2. Now what happens? I3 equals V by R3. Now we got 4 values for I. Right, now substitute all the values in equation 1. So what happens? I is what? V by R. V by R is equal to I1 is V by R1 plus V by R2 plus V by R3. Now we have V as common. Therefore, divide V on both the sides. Divide V on both the sides. So what we will get? 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. This R we can call it as RP since we are studying under parallel. P indicates parallel, S indicates series. This is called as equivalent resistor of parallel. Therefore, the formula for resistors in parallel is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by 3, so on. We will recall what are the points we learnt under resistors in parallel. The first one, the potential difference across each resistance is same and equal to the potential difference across the combination. That is nothing but V is equal to V1 plus V2 plus V3, and we saw all V's are same. And the second point is the total current is equal to the sum of the current through each resistor. That is nothing but I is equal to I1 plus I2 plus I3. Here we got all the 3 different values of current. And see, the last point is the RP. RP means what? RP, that is equivalent resistance. The equivalent resistance is lesser than the least of all the resistance in the combination. That is, this value, RP value, will be lesser than the any one of these resistance. So these are the 3 points which we need to learn under resistors in parallel, and learn how to derive this formula also. Now let us solve few problems related to resistors in parallel. So make sure you should not forget this formula. What was the formula for series? Series is Rs is equal to R1 plus R2 plus R3. So today we are solving using parallel formula. These are our in-text questions. See our first question. Judge the equivalent resistor when the following are connected in parallel. We have A and B. In the first one, 1 ohm and 10 to the power 6 ohm. Look at the question. Judge the equivalent resistor. What is equivalent resistors? Rp. So 1 by Rp is equal to 1 by R1 plus R2 plus so on. So let us solve our first question. So we have only 2 resistors. So our formula will be 1 by R1 plus 1 by R2. Substitute the values. What is our R1? That is 1 plus R2 is 10 to the power 6. Now in this part you already learned in your previous classes. That is how to take LCM here. Okay. So here in the denominator the greater number is 10 to the power 6. So how to write numerator here? See, if we multiply the number, from 1, we should get denominator as answer. So 1 into 1 we will get only 1. 1 into 10 to the power 6, how much we will get? 10 to the power 6. So this is our first numerator, and here from which number if you multiply to 10 to the power 6, we will get 10 to the power 6, that is from 1, right? So 10 to the power 6 into 1, how much? We will get 10 to the power 6. So here the answer is 1. So this is just an extra, no need to write. Just understand how to write the numerators, okay? Now 10 to the power 6, write it in the form of numbers. How much we'll get? 10 to the power 6, that is nothing but 1 into 10 to the power 6. So 1, we have 10 to the power 6 means 6 zeros. 6 plus 1. So plus 1 means what? If we add, we will get this one. And 10 to the power 6, 3. Okay. See, now it's a very important point. Observe, the answer is in this form, 1 by Rp. But we need to give only Rp value. So if we reciprocal this, we will get Rp value, that is Rp divided by 1 is nothing but Rp, and this side also it will reciprocal. So what happens? 1 0 0 0 1. So we'll get like this. Calculate, divide this, and you will see we will get 0.999. And what is the unit for the resistor? That is ohm. This is almost equal to 1 ohm, right? What is our question? Judge the equivalent resistor. So our equivalent resistor is 1 ohm for the first question. Now in a similar way, solve for B. See here, same formula. We need to add one more resistor. Directly I am going to substitute 1 plus 1 by 10 to the power 3, 1 by 10 to the power 6. Now denominator will be 10 to the power 6. In the similar way, calculate and write here 1 into 10 to the power 6, we will get 10 to the power 6. Here 10 to the power 3. Now see, this is again one more important point here. Make somewhere as a note. Now we have 10 to the power 3, right? 10 to the power 3. Let us call this as m and n. It is in the formula of m and n, that is a to the power m and a to the power n is equal to a to the power m plus n. Note on this formula. Here we should not multiply the powers. We need to add the powers based on this formula. So here we should not take like 10 to the power 3 into 10 to the power 2, so that we'll get 10 to the power 6. What happens? 10 to the power 3 into 10 to the power 3 equals what happened? 10 to the power 3 plus 3, how much we'll get? 6, right? So here the answer is 10 to the power 3 plus 10 to the power 3. So remember this key point, make a note somewhere in the notes. So next is 10 to the power 6. So here 10 to the power 6 into 1 will get 10 to the power 6, right? So what will be the answer? Add all this number, we will get 1 0 1 and so it's in the form of 1 by Rp. So what is our next step? Reciprocal of Rp. Rp is equal to 10 to the power 6 will come to numerator, and here we have, then calculate and see how much we will get. Here also we will get 0.999 ohm, which is almost equal to 1 ohm. So both has answers 1 ohm and 1 ohm. Problems are very easy, don't confuse. Just you need to substitute and calculate a proper LCM, and you need to calculate properly. So I think you understood how we got this number, right? 10 to the power 6 means we have 6 zeros, and 10 to the power 3 means 1000. So 1000 here and 1 here. Now add 1 0 0 1 0 0 1. This is our value. Next question is, An electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. So see that here they are given R1 is equal to 100 ohm, that is resistance of electric lamp, and R2 is 50 ohm, that is resistance of a toaster, and R3 is 500 ohm, that is water filter resistance, and the battery source is 220 volt. So these are the given terms here. What is the resistance of an electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it? Read the question carefully. They are asking us to find out the total current, that is the total current, that is I. So after finding I, they are asking us to find out the resistance with the same source. See, to find out the current, first we need to know R using these three resistors. So I am indicating it as R. The next question they are asking is find out the resistance with same source of a battery. So I'll name it as R dash. Understand the question? We need to find three terms here: R, resistance, then using that we need to find out current. After finding the current, we need to find out the resistance. So let us solve. First draw the diagram. Look at the question and draw a circuit diagram. These three resistors are connected in parallel with 220 volt battery. The circuit will be and this is connected to battery R1, R2, R3. This will be battery, that is 220 volt. See, I am not writing. We can write this like this also, and like this. Later we can connect this to battery here. Just we need this much for this problem. So here, see, these parallel circuits are connected to X and Y terminals. So we can say that these resistors are connected to the same terminal, which is the definition of parallel resistors. Now let us find out R. First one. So we know the formula: 1 by Rp is equal to 1 by R1. I'll directly substitute. What is R1? 100 plus 1 by R2 is 50 plus 1 by R3 is 500. Now calculate. So here we'll get 500. 100 into 5 will get 500 plus 50 into how much? 10. We'll get 500. Here 500 into 1. So these are the values. Now calculate 5 plus 10, 15 plus 1, 16 by 500. This is in the form of 1 by Rp, reciprocal of it. Rp is equal to 500 by 16. 500 by 16. Now we find our resistance, that is 500 by 16. Let it be like this. Now we will find out current. We know that from Ohm's law, V is equal to IR. We need to find out I, right? I will be V by R. We know V, that is 220, and what is our R? That is nothing but equivalent resistance, that is 500 by 16. 500 by 16. What happens when we simplify it? We'll get 220 into 60 divided by 500. Now calculate, you will see 7.04 unit of current is ammeter. So this is our total current of the circuit. Now using this current and with the same source of battery, we need to find out R dash. Here we'll use the same formula. So we'll just alter the formula. Let it be R dash. R dash is equal to V by I. So substitute. V is what? 220. I is 7.04 and calculate, we'll get 31.25 ohm as answers. 31.25 ohm. So this is very simple problem. Just you need to understand the question. We solved. The first one is resistance, then current, then the actual resistance what they asked in the question. Our next question is, how can three resistors of a resistance 2 ohm, 3 ohm and 6 ohm connected to give a total resistance of 4 ohm and 1 ohm? Understand the question. Here they are given 3 resistors and we need to find out in which pattern if we connect we will get 4 ohm as an answer and 1 ohm as an answer. First let us solve A. So observe we have R1 as 2 ohm, R3 as R2 is 3 ohm and R3 is 6 ohm. So this is something like a trial and error type problem. First we need to see if we connect which resistors in series or parallel we will get 4 ohm as an answer. So here I will take R3 and this is what? R3 and R2. R3 and R2 are connected in parallel with R1. That is R3, R2 are connected in parallel and R1 is connected in series. Let us draw a circuit diagram based on this statement. So here what we have, R3 this is R2, we have a battery and this is how the circuit diagram, this is a rough circuit diagram. So now we need to get 4 ohm as an answer. See first if we have both, this is R1, if you have both series and parallel, solve the parallel, that is R3 and R2, we know the formula, Rp is equal to R3 plus R3, what is the value of R2, that is 1 by 3 plus 1 by 6, so 6, 3 2s are 1s are, we will get 3 by 6. Rp is equal to what? Reciprocal of this, 6 by 3 is equal to 2 ohm as answer. See if they give you this type of problem, you need to calculate before making all these things, so that if you get up this correct answer we can continue. So how much we got? Rp is 2 ohm. So what is our expected value? 4 ohm. So here what we need to do is this answer, that is Rp, later on combines with R1. Rp, that is R3 and R2 combines with R1 in series, R1 which is in series. So what happens? This is 2 ohm plus what is the value of R1? That is 2 ohm. So what is our answer? 2 plus 2, 4 ohm. Hence we got this as our. See, this is very easy. They will give you this kind of questions. Now let us solve second one, that is 1 ohm. To get 1 ohm as answer, let us connect all the resistors in parallel. So first we have a battery, then our first resistor, this will be our R1, R2, R3, this is battery. So don't get confused, like this is as series. All the three resistors are connected to the 2 points. Now what is our formula to calculate parallel? That is 1 by Rp is equal to, we have 1 by R is 2 plus 1 by R2 is 3 plus 1 by 6. So 6, 2, 3 2 plus 1. Here we'll get 5, 6 by 6. So Rp is again same reciprocal of this. We'll get 1 ohm as answer. Next question is, what is A, the highest, and the second one is the lowest total resistance that can be secured by combinations of 4 coils of resistance, 4 ohm, 8 ohm, 12 ohm and 24 ohm. Look at this question. They are asking us to find out highest and lowest value with these 4 resistors. R1 is 4 ohm, R2 is 8 ohm, R3 is 12 and R4 is 24 ohm. Now to get highest and lowest, let us solve in both combination, that is parallel and series, and see where we'll get highest and lowest value. First we'll solve in series. So series, we know formula, Rs is equal to R1 plus R2 plus R3 plus R4. So substitute all the values, 4 plus 8 plus 12 plus 24, and see how much we'll get. We'll get 48 ohm. So now we'll solve in parallel. So here in parallel we know the formula of parallel. So directly we'll substitute 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So we'll get 24 here. So how much we'll get? We'll get here 6, 3, 2 and here we'll get 1, and see how much we'll get. So we'll get 12 by 24, and this is in the form of 1 by R, and reciprocal is 24 by 12, that is 2 ohm. Now observe the values of both the combination. So what happens in the first combination, we got 48 ohm as answer. So the next one we got 2. So here this is highest value. So we will get highest value when we connect all the resistors in series. This is our first one. And we got lowest value when we connect all the resistors in parallel. See, this is very easy question. You can easily score marks from this. Electricity chapter is mainly problem oriented, less weightage to theory and more weightage to problems. So when you solve a number of problems, it will be easy for you to understand. Go through it and solve again and again till you understand. In this class and earlier class, we understood what happens when resistors are connected in series and parallel, right? In the next class, we'll see the advantages or disadvantages between series and parallel. That is, we'll compare between series and parallel resistors. This 6 volt battery and a key, and we had 3 resistors, that is R1, R2, R3, 5 ohm, 8 ohm and 12 ohm. Here they are asking us to insert the ammeter to take current reading. So let us insert ammeter here, and they are asking us insert voltmeter across the 12 ohm resistor. Which is our 12 ohm resistor? That is R3. Therefore, voltmeter should be inserted here. Now but they are giving some data. Using that, we need to find out current and voltmeter, that is potential difference value across the resistor 3. Now, first we'll find out the first question, that is current. So here, to find out the current, we'll use Ohm's law. What is Ohm's law? V is equal to IR. I will become V by R. Do we have R here in the given data? They are not given equivalent resistance. They are given the value of 3 resistors. So first find out RS is equal to 5 plus 8 plus 12. Overall we will get 25 ohm. So this is our RS. Now substitute these values in this equation. That is I is equal to V is what? 6 divided by 25. This is our total resistance, and the current will be 0.24 ammeter. See, we solved the first question. Now let us go for second question, that is to find out the potential difference. So in the second question, potential difference. Now what is the formula for the potential difference? We'll use the same thing. V is equal to IR from Ohm's law. V is equal to IR. Which R we should use here? They are given in the question, that is we need to take only R3, third resistor, that is 12 ohm, and I is, which we find out earlier, that is 0.24 into 12. Now see how much we'll get. We'll get 2.88 volt. We can conclude reading of ammeter is, that is current, how much we got? 0.24 ammeter, and the reading of voltmeter is 2.88 volt.